go over this problem. We need to simplify each of these expressions. You should have your formula sheet right next to you. I look at this problem and it tells me cosine squared 7x minus sine squared 7x. In these problems, here's my hint. Focus on the angle. Together on the count of 3. 1, 2, 3. Focus on the angle. Okay? As one student said at the end of the period, they realized, wow, it's just all about the angle. It's really not about anything else. So the first thing I'm going to do is I'm going to look at this formula here, look at this identity, and look at one of your identities that looks like this. Put your finger on it. That looks like the double angle identity of cosine, and the specific one that it looks like is cosine squared theta minus sine squared theta. So you're going to write it right below it. Why do you always write down the formula? Same, different, same, 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 different. In this problem, theta is equal to 7x. Class, which formula is this? The double angle identity for cosine. Do you see that? So we're kind of working backwards and you kind of see what's happening. And then all I have to do is put back theta. Theta is equal to 7x. So I have cosine of 2 times. Remember, anytime you do a substitution, you put in parentheses. 7x there. And 2 times 7x is cosine of 14x. Yesterday's lesson, we went from here, cosine of 14x. Does that make sense? And you can separate, you have 2 times the angle. Well, that's your theta. Then you wrote down the formula, you do your substitution, and you would end up like this. So basically, we're just working backwards from yesterday's lesson. Let's try the next example. A little more difficult. This is not a typo. Go ahead and take 20 seconds. Put your finger on the identity that kind of looks like that. Show your partner.
Yeah.
Class, what does it look like? For sine. Okay, look. We're missing a what?
2.
Okay, so I have a question. In math, if I write a 2 here, is that okay? Is that legal?
No.
No, that's not.
You also
What could I put here?
1/2.
Someone said we can divide by 2 or 1/2. Because class, what is 1/2 times 2? 1. And that gives us the original equation. So you can do this. Partner A, tell partner B, what is the identity we're going to write below that? Class, help me write this with theta. Ready, set, go. 2. In today's lesson, you need to do what? Focus on the angle. Class, what is the angle? 15 degrees. Let's highlight that. We're focusing on that angle. So now I can write 1/2. And which identity is this, class? Double angle identity for sine. Now I can put back theta. So now I can write 1/2 times sine times 2 times what? 15 degrees. 2 times 15 degrees. That's why they call this the double angle identity. So now I'm actually doubling the angle. What is that? Sine of 30 degrees. Sine of 30 is on our unit circle. Without looking at your unit circle, partner A tell partner B, what is sine of 30? Go. Now look at your unit circle. Confirm. Pause on the count of 3. 1, 2, 3. 1/2 times 1/2 is? Our answer in this problem is. So when you're working backwards, they've basically given you a filled out identity, right? Pick the identity, write the formula below. Everyone say write down the formula. Figure out what's different. Focus on the angle. Write down the formula. In this case, is the double angle identity.
Okay.
Substitute it back in, and then simplify as much as possible.